Yeah,
what's it called?
No.
Alright, solving
That's not what it's called.
ax squared plus bx plus c equals 0 by factoring. Oh, that's the wrong button. Alright, so the difference is now there's a number in front of the x squared term. It could be just a negative sign, meaning it's negative, but that means that there's an extra step that we have to do or to show. So, number 4, and these are all basically factor the expression like if possible. So there will be an occasional one that can't be factored. So 3n squared plus 7n plus 4. So arch method, we do 3 times 4, so I need factors of 12 that when added together give me a positive 7. So what would that be?
4 and 3.
3 and 4.
Yep.
Why'd you say it backwards?
Now, when you write the next step, I try to look and see, okay, what number pairs up the best with the number that's already there. So I'm going to put the 3 with the 3 and the 4 with the 4, but that's really just a personal preference and what I think makes it easier. If you don't do it that way, it's totally fine. But we have 3n squared plus 3n plus 4n plus 4. So all I've done is rewritten that middle term so that I can factor by grouping. So we factor by grouping the first terms and the last terms. So then once I get here, which was part of why we had the problems at the end of the last section that you had where you had to factor out the common factor, is because it's getting you ready for this. So I have a 3n in both pieces, so I can take out a 3n, and I'm left with n plus 1. Sometimes when people take out this 3n, they're like, oh, there's nothing left. It's like, no, there's a 1 left. You just factored it out. And then over here, I can take out a 4. Now, I don't usually write the little, plus sign. I only really write if it's minus. Just know that those are the pieces of the factor. It's not being, multiplied by this n plus 1. It's, a completely separate piece. And I'm left with n plus 1. So the stuff that's in parentheses has to match. If it doesn't, you've done something wrong. Okay? So the stuff that's outside makes 1 parenthesis, so 3n plus 4. And then we only write this stuff in parentheses 1 time, so n plus 1. So this one's 3n plus 4 times n plus 1. And again, order doesn't matter which one you write first. All right, 6. 6p squared plus 5p plus 1. So arch method, I need factors of 6 that add up to give me 5. And you don't necessarily have to write this either, like what I'm doing over here to the side. Once you kind of just naturally see it, you don't really have to write that, but some of them are harder and it's easier to see by writing it out.
So are you multiplying the first term and the last term?
Yes.
Okay.
Oh, okay.
Yeah, that's getting multiplied, and then I have to take in whatever that is. I need 2 things that when multiplied give me a positive 6, and when added give me a 5.
3 and 2.
Yep, 3 and 2. Some people will say, oh, 6 and negative 1, but when I multiply 6 and negative 1, I don't get a positive 6. Okay, so that's why you've got to watch that too. That's why I write it the way that I do. So this one doesn't really matter which thing you pair with what. I'm just going to pair the 3 with the 6. So 6p squared plus 3p plus 2p plus 1. Now we factor by grouping. What can I take out of this first grouping?
3p.
3p, and what am I left with?
2p plus 1.
2p plus 1. And what can I take out of this last one?
1.
Yep, just a 1. It's kind of a trick question. 2p plus 1 is what's left. Parentheses match, so I'm good. So I have 3p plus 1 times 2p plus 1.
Yeah, I got that.
All right, let's get into some that are a little more complicated. Number 10.
Yay.
Do you want us to show the arch method or
No, you don't have to show that. I'm just doing it so y'all know what I'm doing.
I've been doing it.
I don't usually write it unless I'm teaching it. All right, 14m squared plus m minus 3. All right, so I need factors of whatever 14 times negative 3 is. Negative 42 to add up to give me a positive 1.
7 times -6.
Yep, 7 and negative 6 because they have to be opposite signs, but the middle term is positive, so that means the bigger number has to be positive, smaller number has to be negative. So in this one, this is one where I would say I'm looking, 7 doesn't really pair with 3, 6 could pair with either one. Yeah, it's obviously negative 6. But 7 does pair with 14 well, so I'm going to do that. If you do it the other way, you will get to the same end answer. Your middle step's just going to look different in terms of what you're factoring out. So 14m squared plus 7m minus 6m minus 3. So what do I take out of the first one? 7m. And I'm left with 2m plus 1. What do I take out of this one? Yep, negative 3, and I'm left with 2m plus 1. And sometimes, just so that you're aware, this one isn't one that this happens with, but sometimes a sign may be backwards to the point where both things may not have like a negative in common like this one did, but you still need to take out a negative to make it look like the other one. So just be aware of that. We should have one like that in a minute, but I'm just making sure that you understand that. So 7m minus 3 times 2m plus 1.
I say reach up.
All right, factoring with special patterns. So what are my 2 special patterns that I can have?
Perfect square.
Perfect square trinomial. What's the other one?
And then difference between
Difference of squares. So 14 4r squared minus 25. So notice the difference in these ones and the one we had yesterday is there's now a number in front of the first piece. So I need to be thinking, okay, what's being squared as far as when I go to write this? So 4 is what squared?
2.
Yep, 2 squared, and 25 is what squared?
5.
5. So which special type is this one? Difference of squares.
What is the difference?
I will also tell you that on occasion on the quiz and or test, I may say that if you recognize it's a special type and you write the correct special type, that you get a bonus point. So make sure you read the instructions to know if that's the case or not. So this is really, just for reference, 2r squared minus 5 squared. Okay? So how would this factor then?
2r minus 5 is 2r plus 5.
Yep. So one's minus, one's plus, and it's just basically the numbers copied exactly.
It's weird how I know how to do
Well, you should have learned this in Algebra 1. This should be
this.
review.
Then it's not weird that I should know. Do you remember this? Yes, I remember how much.
All right, 16. 16s squared plus 8s plus 1.
Oh, perfect. No ways.
Think about it, Daniel.
You got it.
Think about it.
I believe you.
Think about it.
How many terms are there?
3. Perfect square trinomial.
So if there's 3 terms, it has to be a trinomial. If there's 2, it's a difference.
That's square.
But is it a perfect square trinomial?
Yeah, think about it. Yeah, solve it.
I
Well,
don't think so.
this particular section says factor with special patterns, so it's going to be.
Okay.
But I will show you why it is in just a second.
I don't think I recognize it just from
So you
the.
have to
It is a little harder to recognize them when there's a number in front. So, this is what squared?
4s.
Yep, so this is 4s
4s.
squared. What is this?
That is 1.
1 squared.
1 squared.
4s plus 1.
Okay, obviously 1 doesn't need a squared on it, but for reference. Then the middle term is 2 times the first term times the last term. And when I do that, that gives me 8s, so it is a perfect square trinomial.
4s plus 1 squared. Right? Oh, it is. I'm so glad I wrote it.
So middle term always, the sign is always off the middle term, so this is going to be plus. So it's the first term,
Plus.
whatever the sign is, the last term, and then the whole thing squared. So this is 4s plus 1 squared.
Now what I don't like is when the middle is negative.
Now, if you didn't recognize that this was a perfect square trinomial, you could have still done it the way that we did the first several that we did, and you'd get to the same end result. But I don't want you to write it like this. Okay, even if you work it out the long way and you're like, I didn't recognize it, that's fine.
See?
But you need to write it like this because that is the technical correct way to write it. All right, 18. 64w squared plus 144w plus 81.
Don't it's gonna be 8. Wait. Oh, that's an 81, so it's gonna be a. So you gotta figure out factors of 12. I think it's gonna be 12.
The first one is 8w squared, right?
Yep, so this would be 8w and that whole thing squared.
And the second one is 12 squared. No, or the last one is 9 squared. 9 squared.
Yep, so then the middle term is the first term times the second term times 2
Yes.
to show you that it's a perfect square trinomial. I don't want to say all the time, but a lot of the time, if the first one is something squared and the last term is something squared, it's almost always a perfect square trinomial. It is beneficial to look at the middle term to verify, but in this case, this would have been 2 times 8w times 9. That would have been 72 times 2, which would be 144.
Wow.
So what would this
I got you.
be?
8w plus 9 squared.
8w plus 9 squared.
I like when you do perfect squares. And you can put a perfect rectangle on it.
All right, next thing.
Stop saying
So these aren't necessarily perfect square trinomials. Number 22, 12x squared minus 4x minus 40.
No, you have to do the plus and minus one. That means we have to switch it all around.
Or you could let me tell you how you're going to do this problem.
Okay.
What do all of these numbers have in common?
4.
4. So the first thing we should always do is we should look and see, is there anything I can factor out before I actually start the problem? So in this case, everything has a 4, so I can factor out a 4. So this is going to be 4. I usually use a bracket after that because I'm still going to be factoring. It's not the only thing that I'm doing. 3x squared minus x minus 10. And now, this is much easier to factor, right, than trying to figure out what 12 times 40 is and then figuring out, okay, what adds up to give me negative 4. Okay, you can but it's going to make it a lot more difficult. This is going to make it way easier to deal with. So now I need factors of negative 30 that when added together give me a negative 1.
5 and negative 6.
Yep, negative 6 and 5. So this middle term is negative. That means that my bigger number needs to be negative. So don't forget about the 4 out front. If you lose that 4, your answer will be wrong. So I've got 3x squared minus 6x plus 5x minus 10. Factor by grouping. Don't forget the 4. What can I take out of the first one?
3.
And
X.
Oh, X.
so 3x. And I'm left with x minus 2. What do I take out of this one?
5.
5. And I'm left with x minus 2. So then my end result is 4 times 3x plus 5 times x minus 2.
So, if we're doing this and the problem says 12x squared minus 4x minus 40 equals 0, can't you just divide like both sides by 4 and then just not worry about the 4?
Yeah.
Okay.
So if this wasn't equal to 0, let's just say I waited to set it equal to 0 until I got to the end. 4 is going to go away, and then I'd set each piece equal to 0.
Okay.
Good teamwork now.
Because 0 divided by 4 is going to be 0. So, but yes, you could do that right from the start, or you could wait till the end and do it where we are now. Um, 26. 12m squared minus 36m plus 27.
Okay, I like it. Shepherd did it.
He's not even
All right, so do these have anything in common I can take out?
Yes,
here. Yes.
a big 3.
6.
I can take out a
Charlie.
6 doesn't go into that.
4. Let's
3.
So I can take out a 3. And I'm left with 4m squared minus 12m plus 9.
We could do this the easy way or the hard way.
What's the easy way, Zach?
Use your head.
Calculator.
Calculator won't do this for you.
So you could either use 4 and 1
Photomath.
and then go through all the options, or you could do 2m and 2m. It makes sense the way I'm saying it, but you probably
Does
not
it?
too.
All right, what's this?
I'm
Oh.
thinking we need 2 m's.
Okay, it's 2m squared.
That's 2m squared. What's this?
A 3.
3 squared. Middle term, 2 times the first term times the last term. So 2 times 6 is 12 times m.
Perfect square.
This is now a perfect square trinomial.
With the 3 outside.
Up here at the beginning, you would not have known that. But this is now a perfect square trinomial. So 3 times, what is the factor?
Oh, it's 3 times 2m plus 3 squared.
2m what?
2m plus 3 squared. Minus.
Minus. Middle term is negative, so 2m minus 3 squared. So sometimes by factoring something out to begin with, you make your life easier because it ends up becoming a special type, typically a perfect square trinomial. All right. The last step in this section is to
Substitute.
solve the equation. So we're just taking these and setting them equal to 0. Did we feel okay about that in the last section? Okay, I'm probably only going to do 1 or 2 of these then because you did them. I decided I was just going to go ahead and teach the whole section, and then tomorrow y'all have the whole class period to work on these problems.
Yes, I like
Sounds
that.
good.
I like that idea.
As long as, you know, you
Except I don't have the study.
don't all do them all tonight.
No, or in a study hall.
No.
Ah, no study hall.
34. 14s squared minus 21s equals 0. So this is kind of like the problem that y'all were asking about a little bit ago, in when y'all were doing your homework. So I need to first factor out like common factor. So what would that be?
3. Oh, 7.
7s.
7s, and what does that leave me with?
2s and 3.
Minus
2s minus 3. So then I take and set it equal to 0. So this is just that 7s equals 0, and then 2s minus 3 equals 0. So s equals 0. Over here, what is s going to be?
Negative 3 over 2. Positive 3 over 2.
Positive 3 over 2. So we add the 3 divided by 2. So s is 3 over 2.
I don't like fractions.
No, it's fine.
No, fractions are not.
I said it's fine.
38.
Got it.
15x squared plus 7x minus 2 equals 0.
Now we actually have to give it. Oh, I see it. 5x plus 3.
So I need factors of negative 30 that when added together give me a positive 7.
10 times -3.
Yep, 10 and negative 3. So this is one where it really doesn't matter which number you pair with it. I'm just going to pair the 10 with the 15. So 15x squared plus 10x minus 3x minus 2. Factor by grouping. What do I take out of the first one?
5x.
And what am I left with?
Then
3 and 2.
3x plus 2. What do I take out of this one?
-1.
Yep, take out a negative 1 and I'm left with
Then 3x plus 2.
3x plus 2. So now I have 5x minus 1 not equals times 3x plus 2 equals 0. Take each piece and set it equal to 0. So 5x minus 1 equals 0 and 3x plus 2 equals 0. So what does x equal in the first one?
Negative 1 over 5.
Not negative.
1 over 5.
1 over 5. And what is this one?
Negative 2.
Negative 2 over 3. All right. Any questions about any of that?
No.
Homework time. Ryan, we should do this in our study.
Let's start it off.
All right. So
Stop.
No. Oh, we expanded.
3 through 39,
Only the last 10 seconds of code.
every other odd.
Ew. That's not something is like the last bit of my notes.
Yes, that's fine. And tomorrow you'll have the entire class period to work on these and ask questions if you need to. Thursday we'll review for a quiz on Friday.